Hello again. Welcome back. We're here. This is the second problem on worksheet 3. So the first problem was a bit of a warm-up to linked lists. This one is going to be a more kind of serious linked list operation. This is probably the hardest problem on this particular sheet. It involves both recursive and iterative things. There's a lot of variables, so this is probably a bit of a step up for you based off what you may have done in like 621A and everything. So let's get started on skip me. So skip me is actually you do the same task in two different ways. Basically, it's giving you a linked list and it's telling you to return another linked list or a modified linked list of the elements that are skipped. So if it gives you 1, 2, 3, 4, it wants you to return 1 and 3, right? Just every other element starting from the first or 0th element, if you want to say it that way. Okay, so the big thing here is we do it destructively and non-destructively. So let's talk a bit about what that means. So if something is destructive, it means that we are changing the actual list that is being passed in. If it's non-destructive, we are not changing the list that is passed in. So notice the first one is destructive. Notice it returns void because we are going to pass in a list L and we're going to change the pointers in that list to give us what we want. So just so I can draw a picture and make it a little bit more clear, let's say we have L. And let's say it is 1, 2, 3, 4, and I'm going to do a 5 just because I think it makes the question a little clearer, even though the example is only 4. Whoop, never mind that. So 1, 2, 3, 4, 5. At the end of 5, we have a null, right? And we have this one is ugly and sticking out, so I'm going to redraw it. Okay, anyways, so basically, if in the destructive version of this, what we want is we want to actually manipulate the pointers within L. So what we're going to want to end up with is something like this. We're going to want to change this pointer. So it's pointing at 3. And we're going to want to change the 3 pointer. So it's changing at, or it's pointing at 5. And then the 5 pointer, we don't have to change because there's no 7, right? There's not enough elements for it to continue. And if we had an even number of elements, like say we stopped at 4, 3 would just be pointing at null, right? Because the next of 4 would be a null. Okay, so that's basically what we're trying to do. Notice that the original linked list is destroyed, right? So if we now call l.next.next, for example, after running this method, we're going to get to this third node. We're going to get this fifth node if we call l.next.next. Right? There's no way to get the 1, 2, 3, 4 back. In fact, you may notice that there's no way to get to this 2 node or this 4 node at all. So this is all going to get garbage collected by Java. It's not even going to exist after this method is run. That's what we're trying to do with the destructive version. With the non-destructive version, what we're going to do is we're going to create an entirely new list that's going to have the elements 1, 3, and 5 in it. So we would have something like L2. It would have copies of everything. 1, 3, 5, just like this. Right? I know it's kind of small, but notice that L in entirety is still intact. None of its pointers have changed, none of its values have changed, and we're returning this other list that we've created. That's also, again, why this one returns void, because we're just modifying the original list, and the original list will be in whatever state we want it to at the end of this method. And that's why this one, the non-destructive one, returns an actual, you will notice, returns an actual int list, because we're returning a new list, right? We're not modifying L in any way. Okay. So let us get to it and start. My screen's being a little finicky right now. And start on the destructive version. So let's look at this code here. And let's see what we notice about it. First thing we're going to notice is this is called skip destructive. It has a call to skip destructive in it. So this is a recursive method. So that's immediately going to tell us we need to approach this recursively. And hopefully you can kind of see how we would approach it recursively, because it looks to me like all we need to do is basically iterate down the list and change a couple pointers as we go down, right? This is a lot simpler than a lot of other recursive things where you kind of go all the way down to the list and change things on the way back up. No, we don't need to do that. Okay, so if it's recursive, what's the first thing we need? The first thing we need is a base case. So what is the base case here? Well, there's actually 2 of them, and we can write them as one line. So the first one is if L is equal to null. Because if L is equal to null, we don't need to modify the list at all, right? It's already skipped, basically, because there are no elements. The other thing is if the list is of length 1, well, then we also don't need to modify the list because we're already done right there, right? If L is just pointing at 1 and these don't exist, everything's already been skipped. So I'm going to say or L.next equals null, right? So if either L or L.next is null, we can just return. We don't have to return anything because this is a void method. We just return and the function will stop executing. Now, it is important that we check both of these. It's very easy to forget to do this one, but you need to check both of them. And in general, the reason is because you don't want to end up in a situation where, let's say you're just trying to check this one, right? If L is null, what's going to happen is L is null. So you're going to try to check basically null.next. Null.next is going to give you a null pointer exception because null does not have a next field because it's null. It's not an object. So you need to do that. And remember that when we have statements like this with ands or ors, they do get evaluated left to right. So once this one returns false, it's not even going to evaluate this one, right? So if L is null here, it's not going to evaluate it here, which is why it's safe to do it in like one line like that. Okay. It's an easy thing to miss though, so if you missed it, don't worry about it that much. Okay, now let's look at the actual logic here. So L.next equals something. So what is L.next? L.next is this pointer. Remember, from the first part of this question, we're talking about the pointers, not necessarily the boxes. So L.next is this pointer, and where do we want this pointer to point? We want it to be pointing at this node. It's currently pointing at this node. Okay, so basically, what is that 3 node in relation to L? Well, it's L.next, basically, right? So we can just say L.next is equal to L.next like that. So that will take this pointer and it will put it here, basically, right? Just skips over the thing. And remember, we can call L.next like that without having to worry about null pointer exception because we already know from this line that L.next is not null. It is an object. So we can just call L.next indiscriminately at this point. Okay, that's the actual mechanics here. And now it's time to do the recursive step. Okay, so we want to rebind L to something else. What do we want to rebind it to, right? Well, we want to go to here because we want the next L in the kind of next recursive frame to be 3 so that it will rebind to 5. How do we get 3? Well, we say L.next because that's what it is now. Remember, this is not L.next, even though this one is, because we've just rebound L.next to L.next. So now we just want to pass L.next in, right? And you can see that up here in the picture, that 3 is just L.next at this point because 2 is gone. And just to finish the recursion out, let's imagine that we did this again, that we did take the recursive call. What's going to happen is we're going to get basically another L in another frame. That L is going to be pointing at this 3 as L, and then it's going to say, okay, is 3, is this node null? Nope. Is its next null? Nope. So it's not going to return. It's going to rebind its next to be next.next, which is this 5 node like this, right? And then it's going to call skip destructive again on L.next. Remember, in this frame, L.next is pointing at 3. The reason I have 2 L's is because this is kind of the L from the outermost frame. This is the L in the next recursive call. So then we're going to do another recursive call. This is our 3rd layer deep where L is L.next. This L.next, right, which is the 5 node. It's then going to say, is L null? No. Is L.next null? It is. So it's just going to return. This is going to return. So that variable goes away. It's going to return. It's going to return. And then we're all done. So these things are going to get garbage collected. And now we're all done. So that's generally how this works. The big things to remember, you need to do both these checks here. And remember that we can just call skip destructive on L.next because we've just rebound L.next. I know I said L.next a lot of times, but that's kind of what happens when you're doing these types of problems. Okay, that was the recursive approach. Now let's do the, that was the recursive destructive approach. Now let's do a non-destructive approach. One thing I notice here is that we have a ton of pointers. And so I think this is not going to be recursive. This is probably going to be iterative because you tend to have a bunch of pointers when things are iterative. So let me draw out our list again, because this picture will definitely help us, probably even more so in this method than in the previous one. So let's say we have this, and we want to get this list of 1, 3, 5 going, basically, right? This one is non-destructive, so we can't change any pointers in the L. An important thing to note here is a lot of times students get a little overzealous with the term non-destructive. They think that non-destructive means you can't, rebind any pointers. That is not true. It just means you can't rebind any of the pointers in here, right? But what you can do is you can make another pointer and point at an element of L and then move that pointer, right? I could create pointer P and point it here, and then I could say p.next equals, or p equals p.next and p equals p.next, right? I'm moving this p pointer. Notice that I'm not moving any of the L pointers or anything like in the original linked list. It's very similar to what we did up here in the first problem when we assigned L2 to be an element of L1, right? We just made a pointer and pointing at a different part of the list. That way we can move L2 and it's still considered non-destructive. Right, so the big takeaway here, non-destructive just means that the original list you passed in is not going to be destroyed, but any other little variables you want to put in can be. Okay, and that's exactly what we're going to do. So notice here that we have 3 pointers being created right off the bat. So let's just write variables for them down here. We have pointer, we have ret pointer, and we have ret head. 3 pointers. Let's take advantage of how they're named as hints as to what they're going to be. So we know, for example, we know that we're going to return an int list, right? And we know that we want to return the int list 135, and we know that we can't change L, which means we have to create a new int list because there's no way to return L as 135 without changing it. So we have to create a new int list and return that int list. So I'm going to take that as a bit of a hint that this ret basically is return, and we're going to have these 2 things referring to that new int list we're creating. Ret head is probably going to be the first element of it, and then ret pointer is going to be pointing somewhere else on that int list, right? That means we have pointer left over. Pointer is going to do exactly what I just did in the kind of beginning explanation with P. It's going to go down the length of L at different points and point at different parts of L. So we can move it without having to move L. So taking that as a clue, let's just start pointer off as L, right? Pointing at the same thing. And now we want to start creating our list that is going to be returned in the end, right? Okay, so what is the first element we're going to return? It's going to be, we want to return the list 135, which means we always want to return the first element of L. And we have the first element of L, so we can go ahead right now and put that in here. So ret pointer is just going to be a new int list with L dot item in it, because remember, we're gonna start by putting the first element of L there. So if we have a pointer here, it's going to take L dot item. It's going to make a new thing. Notice that we're not saying ret pointer equals L or ret pointer equals pointer. We're saying L dot item because we're making a copy. Ret head is just going to be equal to whatever ret pointer was because it's pointing at the first element. This is now the head, right? So now we've set this up. Okay, great. So now we have our while condition. So our while condition is going to be kind of the inverse of what we had here. Up here, we were saying if L is null or L.next is null, we want to return. Now, since we're going to be iterating, we're kind of flipping that over, right? We want to make sure that so long as L.next, or sorry, pointer.next and pointer.next.next is not null, we want to keep iterating, right? So it's just kind of the opposite here. So I'm just going to say, so long as pointer.next is not equal to null and pointer.next is not equal to null, we want to keep going. This kind of condition where you say pointer.next is not equal to null is really, really common when you're iterating through linked lists. And we just need to do both of these because remember, we need 2 linked list nodes ahead of us in order to do the skip. So we need to make sure they both exist, right? This notice is an and rather than an or. And yeah, that's basically all we're going to need to do for that part. Also notice that I use pointer here instead of L. The reason for that is because we're going to want to rebind pointer, right? After we have pointer here, B1, we're going to want to rebind it to B3. We can't rebind L to B3 because that would be illegal. That would be destructive. So we're going to rebind pointer instead. Okay, so now let's just look at what we're going to do. So pointer.next, what is ret pointer.next? What is ret pointer.next? It is this null right here, right? What is it going to equal? Well, now that we are inside this loop, we know that basically there's a third element. We know that there is a next. So this is, we want to make a copy of this thing and assign it here. So let's just figure out what that is. So that means that ret pointer dot next is going to be equal to a new int list because we're creating a copy. And what is that new int list? It is the int list that happens when you go to pointer dot next dot item, right? Because remember, we're going to pointer, which is here, dot next dot item, which is this 3. So that's going to create a copy just like this. And now we're going to have this, right? Okay, now pointer. Next thing is, now we're done with pointer. We want to move it down the linked list because we want to get set up for the next iteration. That means that we have to set pointer equal to itself dot next. So because pointer dot next, we want to set it to that 3. This goes here, gets extended like that. This is not destructive because we can rebind this pointer as long as we don't rebind the L pointer. Notice here, I think this is a little bit dumb in the worksheet. Notice that you say new int list of pointer.next.next.item, and then you reassign pointer to .next.next. You could just reassign pointer to .next.next first, and then just say ret pointer.next equals new int list of pointer.item. Would probably be easier. I don't really know why they do it this way. I think it's overly verbose, but if you're working with, this is an example where you got to work with the skeleton, even if it's not even if it's not written as optimally as it could be. Anyways, so finally, ret pointer. Ret pointer, now this probably makes sense, is that in the same way we want to iterate down this list with pointer, we want to iterate down this list with ret pointer. Because remember, the next thing we're going to add is we're going to add the 5 node to here. And we need a way to access that. So we're going to just say ret pointer is equal to ret pointer dot next, right? So this is no longer here. It's now going to be over there, right? Okay, and then just for the fun of it, let's do another iteration of this loop, just kind of on paper. We're going to go back to the while loop. We're going to say if pointer.next is not null and if pointer.next.next is not null. Pointer.next is not null. Pointer.next.next is not null. So we're going to enter this loop. It's going to say ret pointer.next, which is this, is going to be equal to a new int list of pointer.next.next.item, which is this 5. So we're going to create that. Right, just like that. And then pointer is going to be equal to pointer .next.next. We're going to move this top pointer up here down to the 5 because we don't know yet if there are more elements. The computer doesn't, we can see, but the computer doesn't know, so it's going to set itself up for the next one. Pointer is going to say pointer equals pointer.next.next. So we just did that. And then ret pointer is also going to move down the chain one because we need to be ready to add something to this, even if there's nothing left to add. Okay, but there is nothing left to add. After we do this, we're going to run up here and we're going to say, okay, well, pointer.next is not null. Well, pointer.next is null, so we're going to break this loop. Now we just need to return something. What do we need to return? It's ret head. So now it makes sense why we have this ret head, because if we did not, we wouldn't have any way to return the front of the list, right? Because we've gone all the way down the list. Okay, but that's how you do this. Notice that we never changed any of the pointers up here. Inside the L, we had pointers pointing to these things. We never changed any of them, though. And instead, we created these kind of extra local variables to help us keep track of other pointers. Okay, so that is how you do this problem, and I hope this makes some sense.